In our last session, we talked about exponential growth functions where a value is increasing by a constant multiple and it is growing. So as x gets bigger, so does y. So now we're going to look at a graph, an exponential equation that decays as x gets bigger. So we still have the same general format for our equation, y equals, or f of x equals a times b raised to the x power. In this case, a is positive, and b is a number between 0 and 1. Now, in order to get between 0 and 1, that means that we're going to decay, and that is because if 1 represents the whole, 100%, that means if I were to take, say, 3/4, that means every time I'm taking 75% of the amount that I have currently. So it will gradually get smaller and smaller and smaller. Again, just like in the growth, the x-axis is the horizontal asymptote. That means that the graph is going to approach y equals 0, but never actually get there. And our domain and range is very much the same as well. So domain is still all real numbers, but our range, instead of approaching 0 as x is negative, it's approaching 0 as x gets more positive. But the range still is 0 to infinity, even though the graph is kind of flipped around. So let's look at graphing a couple. So we have y equals 5 times 1/4 raised to the x power. So that means that whatever I plug in for x, I'm going to take 1/4 to that power first and then multiply it by 5. So let's make a t-chart. Okay, so I might plug in -2, -1, 0, 1, and 2. If I plug in 0, that means that I am taking 5 times 1/4 to the 0 power. 1/4 to the 0 power is 1 times 5 is 5. So I'm going to cross the y-axis at the point 0, 5. Now if I plug in -1, I have 1/4 to the negative first power. Now remember that means 1 over. So I have 1 over 1/4, which simply just flips the fraction. So I get 5 times 4, which is 20. Now we don't have 20, so if I plug in -1, we're just going to say that that's way up here. And I'm not going to plug in the -2, but we'll plug it in, we're just not going to graph it. So if I plug in -2, that means flip it and give it the 2. So that's going to be 5 times 4 squared, which is 5 times 16, which is a really big number. Okay, so I'm not going to graph that on this particular graph. So let's look at going forwards then. So if I take 5 times 1/4 to the first power, that gives me 5 times 1/4, which is 5/4. So that's a little bit bigger than 1. So I've got 1 and oh, that's not very, sorry. All right, let's try that again. All right. And then if I do, so that gives me 5/4 here. Now if I plug in 2, that's going to give me 5 times 1 squared is 1 over 4 squared, which is 16. So that gives me 5/16, which is even closer to 0. So my graph is going to look something like this. All right, let's try a negative number out in front. All right, so if I plug in 0, I'm going to get, let's change colors here, let's do orange. So if I do -8 times 1/2 to the 0 power, 1/2 to the 0 is 1, so that's going to give me -8, so I have the point 0, -8. And then if I plug in -1, that's going to flip it and give me -8 times 2 over 1, which is -16. So we'll say that that's, I need some space here, so I'm going to erase this. We're going to say that that's down here somewhere. Okay, if I plug in 1, negative 8 times 1/2 is going to be negative 8 over 2, which is negative 4. So I've got 1, negative 4, and then negative 8 to the second power, so that's going to be negative 8 times 1 squared, which is 1, over 2 squared, which is 4. So I have negative 8 divided by 4 is negative 2, and so on. So my graph is going to do something like this. So it's going to approach y equals 0, but from underneath. So if I wanted to talk about my domain and range for both of these, my domain is all real number, and my range, in this graph, it's above the x-axis, so it's 0 to infinity. But here, it's below the x-axis, so it's going to be negative infinity up to 0. Now, we don't use a bracket at the 0 because it's not included. So how do I tell if I have exponential growth or decay? Okay, so regardless of the fact that some of these have like x plus 1 or whatever in the numerator, or in the exponent, I want to look at right now the base value. Okay, so that base value, if it is a number, if a is greater than 0 and b is greater than 1, that means that I am going bigger than 100%, so that would be growth. If I have a number that is between 0 and 1, that means I'm taking a portion of 100%, so the graph is going to decay. Now, the exponent sometimes can cause growth or decay as well, and we're only considering here the values for which a is positive. Now, if you're still not sure, try making a little t-chart and do, say, plug in, x is 0, x is 1, and so on, maybe x is 2, and decide, are the y values going up or down? So if I look at a, my a value is positive, my b value is bigger than 1, so this one would be growth. If I look at b, my b value is a number between 0 and 1, so my value should decay as x gets bigger. All right, if I look at c, 5 over 4, even though it's a fraction, that fraction is bigger than 1. So this function should grow. Okay, now we get something that looks a little different for d and e. Okay, so if I look at 2 to the negative x, what this really means is 1/3 times 1 over 2 to the x. So as x gets more and more positive, this 2 to the x gets really big, so this whole fraction is going to get very, very tiny. So this one's actually going to be decay. All right, so then let's try that with e. Okay, so I want you to think of it in the same manner and see if you decide if that's going to be growth or decay. And also, let's try f. So we're going to get a little more complicated as well with our graphs. So these look kind of like what we were doing before, but a little more complicated. So I've got more in the exponent on this, and I've got a -2. So basically what this is going to do to your graph is it's going to shift the graph originally. Okay, so here's our graphs that we had originally. It's going to take, say, maybe this curve, and it's going to shift it up and down, or left and right. So, okay, how do I know which way it's going to go? I can look at, first, what would I plug in for x to make this an exponent of 0? So I would have to plug in x equals -1. If I plug in x equals -1, I get an exponent of 0, so that would give me 3 minus 2, which is 1. So I have the value of -1, 1. If I go ahead and plug in 0, I actually get 1/2 to the first power. So I'm going to have 3 times 1/2 to the first power minus 2, so that's 3/2. So 3/2 minus 2 is negative 1/2. Okay, if I plug in positive 1, I get 3 times 1/2 to the second power. So that's 3 times 1/4, or 3/4 minus 2. So 3/4 minus 2, so that's 3/4 minus 8/4, so that's negative 5/4, so that's negative 1.25. This point here, let me regraph these points for you guys because they're not lining up the way I want them to. There we go. There we go. All right, notice this particular graph appears to cross through the x-axis, and that's because it is changing. We have shifted the graph to the left 1, and this value here is going to shift the graph down 2, which means our new horizontal asymptote, what you're going to find, if I were to plug in, say x equals 2, the graph is going to approach y equals negative 2, but never actually get there. So I'm going to get a graph that does something like this. So my domain for this graph, change colors here, my domain is still all real numbers. I can plug in whatever I want, but now my range starts at negative 2, but never actually is negative 2, and goes to infinity. So we have shifted it down. That means that my y-intercept, or excuse me, my horizontal asymptote is positive 3 for this next one. And it's shifted to the right 1 in this case, because if I plug in 1, I get a 0. So let's plug in a couple numbers here. So we're going to plug in 1. So if I plug in 1, I get 2/3 to the 0, which is 1. 5 plus 3 is 8. So I get the point 1, 8. Okay, if I plug in 0, I get 5 times 2/3 to the negative 1 plus 3. So that's flipping. That's 2 to the negative 1, 3 to the negative 1. So that's going to flip. So that's 15/2, which is 7/2 plus, or excuse me, 7.5 plus 3. 7.5 plus 3 is 10.5. So that's plugging in 0. Sorry, it's not liking. Let me try again. There we go. So a 0, 10.5 is about there. Okay, what if I plug in 2? That would give me to the first power plus 3. So that's 10/3 plus 9/3. That's 19/3, which is, see, 3 goes into 19 6 times, so it's a little more than 6. So the graph is going to slowly come down and approach 3 from above. So that means my domain, still all real numbers, because I can plug anything in. This graph is going to span horizontally. My range, in this case, starts at 3, but never is actually 3, and all of the graph is above.